Okay, so welcome to day 2 of Unit 1, Forming Life, and day 2 is all about enzymes, okay? And today's big question is, why are some chemical reactions bigger and faster than others? So let's talk about that. Now, some chemical reactions are bigger and faster than others just because the things that you're reacting with are more explosive than other things, okay? But let's say that you have two chemical reactions going on at the exact same time with the exact same reactants. And remember from the last video that reactants are the things that you are mixing together, and those two things are going to react with each other to make a new product. Okay, so let's say that we have two things and the reactants in both are the same. Is it possible to make one of these chemical reactions happen faster than the other, even though the two chemical reactions involve the same reactants? Can we make one happen bigger and faster? Well, you can with these things called enzymes. Okay, so let me explain what enzymes do. Enzymes are these things that we call catalysts. And a catalyst is something that speeds up a chemical reaction. Okay, that means reactions. It speeds up chemical reactions. But it's not enough to just know that it speeds up chemical reactions. We need to understand why, okay? So let's say that we have two paper mache volcanoes. You guys know, you've probably seen this or done this yourself, where you have a volcano and you add vinegar and baking soda into the volcano, and then you get a little bubble of stuff out. Okay? The vinegar is an acid, the baking soda is a base, and when you mix an acid and a base together, and don't worry if you don't know what acids and bases are, that's okay. Just know that whenever you mix an acid and a base together, there's a little chemical reaction that happens. Now, some acids and bases react bigger and faster than others, but let's assume that we're using the same vinegar and the same baking soda in this volcano, and we're using that same vinegar and baking soda in this volcano, only we add a special ingredient. We add an enzyme. Now, everything is the same between these two volcanoes. The only difference is that in volcano 2, we have added the enzyme. Now, what you can expect to happen with this volcano is not just a little dribble out and pour down the sides like in volcano number 1. You can expect a big explosion out of this one. So we know that the enzyme has something to do with making the explosion big instead of making it small. But the question is, how exactly is it doing that? Well, every chemical reaction needs a certain amount of energy input to get the ball rolling. So let's say that you have a hill, okay? Let's say that you have a big, heavy ball at the top of the hill, and you are trying to push that big, heavy ball over the edge and so it can roll down the hill. Now, once you get to a certain point, the gravity will take care of the rest, and the ball will roll on its own. But there is an initial amount of effort needed to push the ball to get it to the edge. In chemical reactions, we call this amount of energy the activation energy. Now, some chemical reactions need more activation energy to get started than others. But with the case of the two volcanoes, because we're using the same stuff, the activation energy, or the amount of energy needed to kickstart that process, should be the same. So where does the enzyme come in? Well, what the enzyme does is it makes it easier for this guy to push this ball to the edge so it can roll down the hill. In other words, enzymes lower the activation energy. They lower the amount of energy you need to put in to get that reaction going. Okay, so what does an enzyme look like? So enzymes are these little molecules inside your body, and they're not just inside your body, they're in other places too, but let's talk about the ones in the body. So inside your body, you may have an enzyme, and these enzymes are certain shapes. They're not really shaped like this, but let's just pretend that this is the shape of the enzyme just for this example, okay? So this is our enzyme, and what enzymes do is they take certain elements. Let's say that these are just elements in the body. Okay? So here's an element, here's an element, here's an element. Okay? And what enzymes do is they take some elements in your body and they change them into something new. So, and they make it happen faster. Remember, by lowering the amount of energy that you need to do it. So, this enzyme will bind to these elements, but not just any element. The element has to fit this shape of the enzyme. This is what we call the active site. The active site is the place on the enzyme where these elements in the body, which are called substrates, where these substrates will bind to. So if you look, you can easily see which one of these three substrates will be able to bind with this enzyme. This enzyme has a square-shaped active site. So element 1, the substrate 1, will bind to it. And out of the enzyme will come perhaps two different pieces that, if you put them together, they make the square. But remember, the square got broken up, and now that happened. Okay? Now, your body would have done this anyway. Your body would have taken this square and split it up into these two separate pieces eventually anyway. But these enzymes, what they do is they make that whole process happen faster. That's their whole job. Not to make reactions happen necessarily, but to make these reactions happen faster. And they happen faster because how much energy your body has to put into turning this into this is much lower. It takes much less effort to do it. So your body can do more of it and faster. And that's what enzymes do in your body. By the way, this model that we're using, where the active site has a shape and the substrate has a shape, this is what we call the lock and key model. Okay? So the lock and key model is what we say when we're referring to how this works. It's like the key fits into the lock and only that key. This won't work. That won't work, and that won't work. Only that one will bind this enzyme. These guys will have their own enzymes that have a right shape for them, but not this guy. Okay, this guy only works with this guy. Now there's two things that can affect how well the enzyme performs. Okay, so let's go back to this enzyme here. It's the same enzyme. It's got the square active site, remember? Okay. Now, this is an enzyme in your body. Your body has to be in a certain condition for it to work properly. If your body gets out of the right conditions, these enzymes don't work, your body can't do its job, and then you get sick or you die. Now, what are the two things that your body needs to maintain in order to be able to function properly? The two things are temperature and pH. pH is how acidic or basic your body is. Okay? So, if your body gets too hot or cold, or if the pH gets too high or low, too acidic or too basic, this enzyme can actually change shape. And instead of being a square, it's now a triangle shape. So this substrate that it's trying to bind to, so we can turn this into this, doesn't work. It will not bind. So temperature and pH, if your body doesn't maintain a very consistent temperature and pH, the enzyme's active site can change shape. And this substrate that it needs to react with to keep you alive will not bind to it, and this will not happen. And your body needs this to live. Okay? Don't worry about what this thing is. It doesn't matter. There's all different kinds. The point is that that is what happens when your body doesn't have the right temperature and pH.